So, hello everybody. Hello to this sunny day. Thank you, you joined our webinar today. And the topic of our webinar, saving resources through advanced sealing and energy reduction. This webinar is in the series of webinars of Invite an Expert, but we have enlarged our topics to keep the planet clean. And I'm glad to introduce our 5 experts for today. Hello, guys.
Hello, good afternoon, everybody.
Thank you. You made this interesting topic today. And just some rules for today's webinar. We are 5 experts of us, so everybody of you will have 10 minutes of your fame to speak about your line. And we will see you later, right?
Okay.
So, and we will start with our Keep the Planet Clean series. As you know, protection of the world's resources and landscape is an integral part of Chesterton's business philosophy, and it's in our operations. So Chesterton's manufacturing efforts, product development plans, and customer solutions focus on resource reduction and environmental awareness. And as you know, we have 3 webinars in this series. We had last month refurbish and repair, aging plants and equipments. By the way, who missed this webinar, you can watch it online on YouTube channel, or when you receive our presentations later, click on the link. Today, the second webinar is saving resources through advanced sealing and energy reduction. And the next webinar in this year will be in December, increasing the useful life of your assets. For more, let's say, dynamic, I invited Enrico Zini for moderation of this webinar as an expert. Enrico, hello.
Hello, Vitaly. Hello, everybody. Thank you for attending.
So, hello, Enrico. Maybe you introduce shortly, if somebody doesn't know you, and I will give you the word to lead this webinar.
Yeah, thank you, Vitaly. So, effectively, the topic of today is related to saving water and energy consumption in the industrial plant. Vitaly, can you please go in the next slide?
Enrico, I gave you the right, so you can click. And for the participants, I will stay in the background. So see you later.
Doesn't seem to work. Okay, so why is that interesting to reduce water and energy consumption for the industrial plant? Because we will see today some examples in many different lines with higher productivity and higher plant efficiency, lower water consumption, and reducing the energy means, generally speaking, saving money. So what we're offering today is to go together the environmental protection together with the savings of cash, simply. So we will see today 5 different ways to reduce water and energy consumption as a direct advantage for the plant, 1 per product line, because you might know that Chesterton has 5 product lines. So that's the reason why we are 5 presenters today. Chesterton designs, produces, and sells protective coatings, for example, but also lubricants and maintenance, repair, overhaul products. We will see some solutions also from the hydraulic seals, together with the packing and gaskets, and finally we will conclude with the mechanical seal division. And we will see that because one of the key differentiations of Chesterton in the market, we have very good and very valuable competitors, of course, that we respect. But one of the key differentiation with Chesterton is that we can improve a equipment like a centrifugal pump, like in this example, but it applies also to valves, to flanges, to cylinders. We can improve that with many different solutions, all from the same brand, all from Chesterton. Talking about, for example, a mechanical seal or a packing. We can also apply the coatings to the wet part of the pump. We can improve the lubrication of the bearings. We can apply the thread sealant or the anti-seize compound. All these products are from Chesterton. We have a full control of the improvement that we are offering you. So I'm very glad to thank you again for attending to this seminar, and we can start with the reducing water and energy consumption with the first expert that will talk to us about efficiency and protective coating. So I'm very glad to give the parole to our friend Nick. Nick, are you there?
I'm here, Enrico. Thank you very much. Yes, and thank you everybody for attending today. So for those that maybe don't know me, my name is Nick Wilson, and I'm the ARC application engineer for the European, Middle East, and African territories that we supply our industrial coatings into. So hopefully I have control here of the presentation. Yeah. What I want to talk a little bit very briefly today is a topic that we have known about and we've talked about in Chesterton for many years, and it's the related to the cost of pumping, and specifically related to the energy usage that is used by industry in pumping. So, you know, some facts and some costs here about what we spend, what industry spends to supply, to work, to operate. You know, pump systems account for approximately 20% of the world's electrical energy demand. Some industries, that accounts for up to 50% of the energy usage that they have to operate. And, you know, going further than that, if we look at the European Union here, pumps are the single largest user of electrical energy. And there's also been a lot of studies related to this going back many years. This is not something new or anything, but a lot of studies have shown that a lot of that energy can be saved, in some cases up to 50%, can be saved just through better equipment design, control system changes. But one of the areas that we can influence with the industrial coatings from ARC is to address the degradation and service of pumps that causes increased energy consumption. And it's something we have been talking about this topic for well over 20 years, but it's something that in this day and age with the environmental concerns, I think it's important to bring this topic back up again. So that's the reason we're talking about it today. You know, if we look at pump systems and we look at the life cycle costs, we may or may not be aware that, you know, the biggest cost for a pump in operation in industry is the energy usage. It far outweighs anything else, particularly the acquisition cost, particularly other costs, even maintenance costs. But it's not the #1 priority given by a lot of customers when they're purchasing pumps. You know, when the customers have been surveyed as to the reasons why or what's their #1 priority when they're choosing a pump, tends to be down to the acquisition cost or the brand name or something else, but the energy cost is typically well down the list of priorities. So we need to maybe educate industry in some of the opportunities, some of the savings that we can offer. You know, these are some photos of pumps that have been in service, obviously. What's going on? Okay, and we may or may not experience some of these types of issues in our plants and in our industries with corroded impellers, corroded wear ring seats and casings, heavy rust tuberculation, as you can see here, damaged cutwaters. All of these will affect, obviously, the performance of a pump system and the energy demand required to move a fluid. So maybe we can change the next slide. For some reason we are stuck. Okay, so yeah, some of these factors that affect pump efficiency include things like the increased sealing gap clearances. So particularly in the wearing seats, you know, as these clearances open up, you're going to have more recirculation, you're going to have volumetric leakage in the pump. And it does depend on the design of the pump and in particular the specific speeds, but some of these losses can be up to 8%, just by a small change. In fact, even 50% increase in the wearing sealing gap clearance can lead to losses up to about 8%. But one of the areas that is even more important is the increased friction and wear as the fluid moves through the pump end and the pump's wet end. So, you know, here we can see some photographs that demonstrate, you know, the sort of surfaces that can exist in even clean water pumps after a period of time due to corrosion. And obviously friction becomes an issue when we're pumping any sort of media through that. And some of these losses, some of these types of corrosion issues can reduce the efficiency of pumps up to about 50% in some cases. Okay. And another important point, I think, to think about is that the loss of efficiency over the lifetime of a pump, it isn't a straight line curve. It occurs like this. And a lot of studies, again, this goes back a good few years, as you can see, to 2001. It was a report done for the European Union, where they looked at a clean cold water pump and where the main efficiency losses were. And in fact, they showed that in the first 2 to 5 years of this pump being in service, that's where the majority of the efficiency was lost. It tends to then plateau for a while until eventually the pump fails in service. And this is an area where we have an opportunity to offer some savings if we can apply a protective coating that can help maintain that efficiency over the lifetime of the pump. Okay, maybe we can go to the next slide. I don't believe I have control of this. So again, you know, this is not new information, and it's not information that's just coming from Chesterton. This is well known throughout the pump industry, and there's been a lot of information, a lot of studies, you know, talking about pump efficiency. And you know, here's a few points from one of the EC European Community Guides here that talks about there's little point in having a high efficiency pump if it's going to lose its efficiency over time. And there are ways to avoid that, you know, to obviously operate the pump within a certain range of its best efficiency point, but also to ask for cast iron casings, for example, to be protectively coated, to avoid the roughening of the surface due to corrosion. So that is something we've been actively working with pump manufacturers, both new OEM pump manufacturers, to promote the use of protective coatings to offer improved efficiencies. Maybe we can go to the next slide. And the one after that. And to provide materials that can help not only improve reliability, we spoke a little bit about this in the previous seminar, where we can offer materials and polymers that can avoid corrosion or reduce corrosion, also that can help reduce the amount of wear. But in this particular scenario, we're talking here about energy efficiency, and that's primarily achieved through a reduction in friction using coatings that basically have a lower coefficient of friction or surface energy compared to an uncoated metal or alloy surface. So we can smooth that surface to get a uniform roughness, a much lower roughness than you would achieve with a investment casted or sand casted pump surface, for example, and reduce the amount of friction when the media is being pumped through. Next slide. And again, this is a study that was done at University of Darmstadt in Germany many years ago, but they looked at what were the possible energy efficiency improvements by smoothing the pump using coatings or by polishing the surfaces. You know, they studied this in detail and looked at, you know, what could be achieved through the whole pump smoothing, and even through the various different parts. You know, if you only coated part of the volute, or you only coated the casing, or indeed if you only coated parts of the impeller surfaces. So you can see there are different amounts of efficiency improvements that can be achieved through the use of smoother, lower friction materials. Next. So we can, okay, yeah, so as I said, we can look to achieve this through addressing new pumps, to increase the performance of new pumps by improving the head and the flow, making smoother flow passages with low surface energy materials, reducing the friction. And this has been shown many, many times to allow us to achieve an efficiency increase up to about 3%. It does depend on the specific speed and the design of the pump, what sort of efficiency and energy savings can be achieved. But no matter what about energy savings, there will always be an improvement in wear and corrosion and the lifetime of the pump. So we can always offer increased reliability over that lifetime. But where we see the biggest opportunities really is in-service pumps, where we can restore pumps that have been operating that have lost maybe 20, 30% efficiency, and we can restore these back to their original design points. And there's even an opportunity to go beyond that, to restore these pumps so that they were better than they were originally when they were brand new put into service. So that has a major impact on the life cycle, because we're reducing that energy cost that we saw, which is the #1 cost of pump systems. We are also able to restore assets versus the purchasing of new assets, and extend the lifetime. So you can see here some photographs of what we can achieve. And finally, I'd just like to say, if anybody has more information, if we can just go to the next slide, or wants more information, remember there's a lot of this information is available on our fluid efficiency website that you can see there. So I know we'll address questions hopefully at the end of the seminar, if there are any questions. So thank you for listening to me. I'll hand over to Ingo Stenner now to talk about chain lubrication.
Yeah, hello from Germany. How are you doing? Thank you very much, Nick. It was a very interesting presentation. First of all, I like to introduce myself for some, for the people who have never met me before. I'm Ingo Stenner. I'm a chemical engineer. I'm working in the area of lubrication since over 20 years now. And for Chesterton, I'm the technical service manager for whole EMEA. So that means, if you have any questions about industrial lubrication or MRO products or applications, please contact me anytime. So I hope I have control. Not yet. Vitaly, can you then go on? That's great. What I would like to give you an idea is, I would like to give you an idea about the Chesterton program, how to optimize the chain performance. Generally, chain performance in industry, we talk about pulp and paper, we talk about steel industry, we talk about any sort of heavy industry. Chains are critical for the process. And chains are also sometimes the Achilles heel of the process. It means, if the chain doesn't work, the whole process doesn't work. So what is the reason for that? And you probably have seen in your area as well that chains creating noise. Chains might be stiff. They're not moving really much, moving too slow. Chains could cause heavy wear and the pin in the bushes. That means, you might have seen chain elongation. Chains are getting longer and longer until they crack. Typically, if this is a critical chain, you will replace the chain before actually the chain will rip apart. So what is the reason? And I'd like to give you an idea what is the main reason and what also a good chain lubricant needs to actually do to overcome this. And there are actually 4 major points you have to remember. First of all, an oil needs to be able to penetrate. If you apply an oil onto the chain, and the oil stays on the surface of the chain, it doesn't lubricate where it should lubricate. It should lubricate, should penetrate into the pin and the bushes of the chain. So it means it has to go through this fine tolerance to get actually into the chain. If the oil stays on the surface of the chain, what does it do? It will collect dust, it will collect dirt, it gets dirty, and even increases the wear and tear of the chain. Means the first point is the oil needs to be able to penetrate into the chain to actually be active where it should be active. The second point, of course, once it's in there, it should be able to keep a very, very good lubrication film. So the lubrication of the chain is always there. It doesn't break and doesn't cause metal-to-metal contact of the chain. So that is the second point of a good chain lubricant. And then last but not least, every oil, also Chesterton oils, are getting rancid after a while. It means they're getting old, and old oils typically are getting a little bit sticky, a little bit stiffer. You might have stickiness there. You might get old rancid oil. It will not perform. It will not give the right lubrication film. So what does a chain lubricant needs to do then? It needs to be able to dissolve the old gunge, the old sticky material, wash it out of the chain, and provide always a very fresh lubrication film on the pin and the bushes. Very simple, but not always there. Then there's the last point. Last point is, sometimes you have also solid particles. We talk about paper industry, for example, pulp and paper industry. You have fiber, wood fiber. In the steel industry, you have metal particles. You have in the wood panel industry, you have wood fiber in there. You have in every industry, you have some sort of a dirt. Glass industry, there's glass pearls, glass particles. Every heavy industry, you see some sort of solid contamination, solid dirt. If that gets into the chain, it will increase wear and tear. It will increase the friction of the chain. And when it increases friction of the chain, the same with the sticky residue, it also increases power consumption, because the same engine, the same motor needs still to run the chain through it, and it has to work much harder to bend the chain to the right position to move over. Vitaly, can you go on? Very good. Just to give you an idea, loads of chains, not all of them, but loads of the chains have in the inside grooves. And the purpose of these grooves is to provide an oil reservoir. So keep in mind, if you have old residue, they will go into the grooves. It will clog up the whole chain, it will clog up the whole pin and bushes. And actually you have even the grooves, the old oil reservoir is now a sticky material. So it means the good chain lubricant always needs to be able to wash that sticky material out. It needs to have very high detergency. Okay? To give you an idea, just a little bit from the practice experience, this is a pulp and paper mill, a paper plant. And what you can see here is on the right-hand side, you see a chain which is clogged up very heavily clogged up with paper fines on the surface. And all the other chains here, they were exactly the same. That means you can see this paper mill lubricated the chains with a chain lubricant or with an oil, which is not suitable for this application. This oil, what they used was too heavy. That means, too high viscosity. It couldn't penetrate into the pin and bushes. And when it got rancid, it could not even clean. So what does that mean? We have a program. We developed a product or several products for lubricating chains. And what the advantage is, it only takes a few minutes and it actually cleans the chains immediately. So how can you see that? Only you can of course see it, that the dirt gets washed away. By the way, just to make sure, if you have a nice floor, for example, put a cardboard underneath, to protect your floor, because the dirt will go somewhere. And the dirt typically runs down and gets straight on the floor, and you can collect it there. But the most important part is the chain will be clean. So how can you actually measure that? You can see it, but you can also measure it by energy consumption. It means if you measure the energy consumption before the application, you make a note of the energy consumption, you spray the chain in, let it run for a few minutes, let it run maybe for half an hour. Maybe you want to do a second application, but in these 20, 30 minutes, you will see the power consumption going down. What does that mean? It means actually the oil from the chain lubricant penetrated in, washed out the old gunge, and you could already immediately see the improvement. This is a nice thing. You can actually get the material, you get the product, you apply it on the chain, and you see it in a few minutes. Does it work or does it not work? And just to give you an idea, Vitaly, can you continue? Next page, please. Very good. Just to give you an idea, this was the result of the chains you just saw in the pulp and paper plant. Very badly lubricated. Unfortunately, they picked not the best oil for that, which got rancid very quickly, soaked up all the dust and dirt. And we actually measured the amperes of the motor beforehand. And then we applied a good chain lubricant onto the chains, let it penetrate in. And after a few minutes, we measured actually the power consumption again. And you could see immediately the power consumption dropped. Worst case scenario, it dropped to around 49%, also nearly to the half of it, the power consumption. Some of them dropped by 14 or 16%. Having said that, this was a case, which was quite extreme. Typically, if you already use a good chain lubricant, the Chesterton program can improve the power consumption by typically between 2 and 10%. That is a typical number which we find in the industry in Europe and in EMEA. But even if you reduce it by 2 to 10%, I would like to calculate that for you, what actually the savings are. Vitaly, can you continue by any chance? So if typically you have 5 to 8% with a good lubrication on energy consumption reduction, means you save energy. If we do worst case and you only have 2% savings, means if you do the calculation here, you have a 25 kilowatt motor, you multiply the 0.2 by 25 kilowatt, you get 0.5 kilowatt hours. I just walked through that, you can do the calculation yourself later on. What does it mean? You get actually over a day $1.20 or €1.20 per day in savings, and over a whole year you get actually 360 euros roughly on savings on your one chain or one single chain. So this product is paid for then. If you already save 360 euros, this product you can consider that being for free because you get the money already back. But the real saving is not the little bit of energy consumption. This is very, very good for the environmental program. For example, sometimes you're on ISO 14000, you want to actually do something for the environment. You can actually do that on the ISO 14000 program, energy consumption saving. More interesting from the money point of view is wear and tear. It means, the chains will last longer. You do not have to replace the chains that often, and therefore you save a lot of money by reducing the replacement parts and replacement part costs. And the third point, of course, is you improve productivity because the chains will run longer. There will be no unscheduled shutdowns, for example, because the chain broke. Therefore, and that is where everybody knows the real money lies, is keeping productivity as high as possible. That is where you get the biggest bulk for the dollar. So, and then I would like to finish my presentation with the question, who says that environmental protection and making money cannot go hand in hand? You actually can make a lot of money and still do something very, very good for the environment and might even support your ISO 14000 program. Thank you very much. And I'd like to give over to Piotr, I think, is it?
Thank you, Ingo. Vitaly, can you switch the slide? Yes, thanks. My name is Piotr. I'm a product line manager for Polymer Seals in Chesterton, with some years of experience and also good background in fluid power and heavy-duty hydraulics, and also rotary applications. So I would like to share with you a little bit about how we can save resources, especially compressed air and the friction and energy using Chesterton modern polymer seals and the low friction seals. Can we switch the slide? Thank you. So first of all, let's have a look on pneumatics. In this case, I have a pneumatic cylinder here with me. So if you are operating such a systems to be able to use pneumatics, you need to provide this kind of energy first. So you need to have a compressed air. How we do compressed air? We are taking air from the air and we use compressor. To operate compressor, we have to have some kind of motor. So simply a compressor is a kind of equipment, kind of machine which is changing energy from, let's say, electricity to compressed air and energy, so the fluid power energy, or we can use a compressor which is based on a diesel motor, for example. But it's again energy and consumption of diesel oil. What is there more in this? Come back, please. What is? No. Previous slide, please, Vitaly. Okay, so the compressor to operate needs the motor which has a power, so we need the kilowatts, and this is where we are having an energy consumption. So when you have a look on the compressors, they are considered as a very high energy consumption machines. Why? Because the efficiency of most of compressors, even the modern one, is pretty low. How we can find that? If you operate any compressor, you will find quickly that it's heating up a lot. Why is it happening? Because the loss in the compressor can reach up to 70%. So we are using electricity and we're losing from that 70%. And how we see that is the heat. So this is one thing. Another thing, if we take into consideration that up to 30% of air which is used in the systems is used for the leakages, just to fulfill the system, just to recover the lost air from leakages. It means that providing compressed air to fulfill these leakages, we are using a lot of energy. So based on that, we can save energy and we can save money. Next slide, please. So to show it a little bit, just imagine 3 clicks that we are having 3 large compressors to provide amount of air which is needed to our system, to your system. So just imagine that if you succeed with elimination of leakages, you can say that one of these compressors is not needed. 1/3, 30% can be cut down, and this is pure savings. Let's go to the next slide then. All right, so let's have a look a little bit deeper in example of a pneumatic cylinder like this one. So let's have a look. Let's have a look how it works, where the leakage is happening. So when you see the cross section of this cylinder, you see on the left side the air pressure is coming in to the piston, and this is causing that the piston goes out. Yeah. So, but in this case, many seals are leaking internally because of wear, because of compression setting, and what is happening then? We are pressurizing. It goes outside, and then we release, and then it blows out to the exhaust. So air loss, which is shown with the arrow, it means that we exhaust all the air which is used inside, but also the air which is leaking. The same is happening when we go to retract mode, when we come back with the rod inside. So in this case, you see we provide air from the gland port. So air pressure is indicated here. So we operate, and the leakages can be in two places. One is through the rod seals here. So we sometimes hear that it's like a snake, that we have a loss of air. We cannot see it, but we can hear that. So sometimes we hear, sometimes not, because it's again inside where the piston is. And then it goes to another point, to the second port, and again is exhaust to the air. How much is that? We can see at these balloons. So just imagine that in this kind of cylinders, the leakage is here, and it's very small hole. So in the medium size, like here we have a 100 by 50 millimeters piston and rod, we can lose something like 31 cubic meters per hour. What does it mean? If we operate, and most of pneumatic systems are operate 24/7, we are losing, like you see on these balloons, the red balloon, we are losing altogether like 700 cubic meters. Then 1 week we lose over 5,000 cubic meters. And in 1 month, it could be even 22,000. So it's a lot. So let's have a look how it's corresponding with what we have to do then. So what we do, we simply pump the pressure in, we pump the air in more and more, because we are losing part of that, and we pump more pressure, so we're using more energy. Next slide, please. Okay, so let's have a look, but what is the problem? The compressed air is not for free. We have to pay for electricity, for example. So in this chart, you see how is the amount of air which is lost during the time, and how is the relation between the size of the leakage. So virtually, it's the size of the hole around your seals, for example, is inside the cylinder. So you can see that if the hole is small, with the 5 bar, for example, you're losing like let's say 38 liters per minute, and it's about 175 euro. But when the hole is bigger and you operate more and more, and if you increase pressure, you can lose like 13, 20, or even 30 or more thousand euro per year, because this is a year consumption. So have a look. It's good to eliminate leakages. It's good to use better solution. Because in this case, you can avoid these kind of problems, and you can save a lot of energy and a lot of money. So for example, using more reliable seals in the pneumatic cylinders, we can make them working better. Okay, the next point is low friction seals. So the question is how we can cause a better utilization of power, a better or less power consumption using modern self-lubricated low friction seals. So this is the question, how it influences, how we can cut down the kilowatts which are used. And I want to share with you the lab testing with the Institute of Stuttgart, which did testing of our seals. Let's have a look. So the laboratory built a special equipment based on several cylinders, which you can see now on the drawing and on the photo. And they were testing in different conditions, different parameters. How are the seals behaving? How is the friction? How is the breakaway force? Let's go to the next slide. So what was, for example, tested was a Chesterton polymer seals made of red and blue polymer, which are low friction Chesterton polymer seals, self-lubricated, very close with the friction coefficient to Teflon, which is very, very low. And then the second one was, for example, NBR rubber seal, a traditional stack set, and they did comparison. So let's have a look at the result of that. So they did many tests and many formulas, but what we see in the result is that even with changing speed and the pressures, what they found is that in the last column, what you see that Chesterton polymer seals, low friction seals, are let's say, up to 3 times and even over 3 times less friction seals than the other ones, yeah, than the old technology. What does it mean? It means that you don't need so much hydraulic power for these seals to start moving the rod, to move the rod, or to move the piston inside. Let's go to the next slide. Okay, so here we have example. If you can click once, Vitaly, it's a large press, and in the arrow you see red arrow shows the rod. It's a 1000 millimeters, so quite big one, but it's nothing special in aluminum extrusion. It's a typical size. And if we have such a press and we just replace seal from the rubber to low friction 11K polymer seal, let's have a look what happened. This is a full formula. You will have it in a presentation. So let's go next slide. And then, yeah, here is the calculation with the power and with the forces. And then the last slide on that, the next one, yeah, and one click more. Okay, here we see, so calculating, come back please. Calculating this formula, you will see that this press is using 1.29 kilowatt difference between when we change the seals per every stroke, by many strokes, like 40 strokes per hour, by 24-hour operation, and almost whole year. This press is consuming, in addition, over 400,000 kilowatts per year if we are using rubber seal. But when you change to 11K, you can save a lot of kilowatts. This is 400,000, and it represents, in average electricity price in Europe, over 32,000 euro. So it's not only the point that we save the consumption, but also you save a lot of money at this energy. So this is how this seal works. And let's go to next slide. So here we have a summary. So changing from rubber to new generation low friction polymer seals, we cause the friction change by 3 times. The breakaway force, so the force which is needed to just start moving, is even less. And then you can achieve a lot of savings in energy consumption. Why? Because you can use much lower power hydraulic pumps. That's one thing. And the second thing is that these formulas are kind of proportional. So this was a large press, but just imagine that if you have 10 times smaller cylinder, so let's say 100 millimeters, virtually you go 10 times less, and it's still huge amount of savings, because it represents, in this case, up to 3,000 euro per year. So this is how polymer seals from Chesterton works to save the planet, to save the resources, compressor, and energy. Thank you very much. I pass the presenter to Mr. Hans Decker, our expert.
Thank you, Piotr. Okay, so hello everybody, good afternoon. My name is Hans Decker. I'm product line manager for EMEA for packings and gaskets, with experience in different areas, but mainly in compression packing, and that's actually the topic I'm going to talk about a little bit. So packings are used in different areas, and one of the areas is rotating equipment sealing. And packing is still widely used because it has some advantages over other sealing methods. First of all, it has non-catastrophic failure. It's relatively not complex, and it's simply in some cases the best available technology for some types of equipment where there's simply no other solution. But when commonly packings are used without paying too much attention, a lot of times flush water is used to cool and to clean the conventional packing. So what you will see is that clean water is injected to keep basically the surface between the packing and the shaft clean, so it doesn't wear too much. So this water is doing a number of things. First of all, the water itself, it needs to be prepared, so it costs money. When this water goes into the system, the medium needs to be reheated, or the water needs to be evaporated again. But as well, and something that I can more clearly show you the effects of that, water that leaks out of the pumps basically is going to drain and has to be treated in a water treatment plant, and this is quite expensive. So, and this is mainly a problem Kevlar packings, natural fiber packings, poorly lubricated packing need a lot of water to keep them cool and clean. And next slide, please. So to reduce this water, and this wastewater is actually quite expensive. It can be water treatment costs on average in Europe, they're about €2 per cubic meter. And if you have a yet of leakage that is about 6 millimeter thick, this could add up to a lot of money per year. So it's quite important to reduce this flush water if you just look at the cost and not even consider the environmental side. So solutions to this are previous slides, please. Solutions to this are mechanical seal, but as well on the packing side, there are more chef-friendly packings that don't need so much water. And on the other side, there are as well highly conductive packings like carbon or graphite packings that basically transport the heat away from the shaft and don't need so much water. And on top of that, we can offer something that is a spiral track or spiral track technology that basically is a spiral shaped bushing that basically, because of the centrifugal action from the shaft, takes away the solids back into the volume of the pump. So that's a very good system. So in the next slide, I'm going to show you an example of a case where we actually applied the spiral track technology in combination with a highly conductive packing. So this is a pulp and paper plant in Poland. Sealing paper stock, relatively large sleeve pumps, chef sleeve, 150 millimeters. They were using a relatively low grade PTFE graphite type of packing that actually needed very high flush water. This is actually quite a lot, 32.6 liters per minute. The solution from Chesterton was a 370, which is a carbon fiber packing in combination with a spiral track, and that's what we call a superset. And we went to a flush rate of 3 liters per minute instead of the 32 liters per minute. So we're able to save 94% of water, which basically led to annual savings of almost 40,000 euros per year. So next slide. Not only on rotating equipment, we can save a lot of money, but as well on valves and flanges. What we often see in, for example, power plants is steam leakage, and they actually cost a lot of money. Basically, every leak costs money, but if we talk about steam leakage, this is actually basically you're burning gas or oil or coal, basically to generate that steam. So any steam that is lost directly means a loss of energy and loss of money. So we have some guaranteed sealing solutions for valves and for flanges that we can offer. And if you go to the next slide, so this steam leakage, we can actually translate it to money very easily. We have this chart here on the left. There are some formulas behind here, but if we have a 6 millimeter leak, diameter of steam leakage, very similar to what Piotr for the air leakage was showing before. At 6 bars, this means 75 kilograms per hour. And we basically, to generate this amount of steam, we need to burn 40,000 liters of oil per year. At an average cost of $35 cents per liter, this adds up to $14,000 per year. So this means that it is actually a very, very good idea to invest in a good guaranteed sealing system, because this will basically save you a lot of money. So to just finalize, I'm going to show you an example of a case that we did in a gas production plant in the Netherlands, where they had some control valves sealing steam, 450 degrees, 80 bars. So the problem was that basically there was regularly some leakage, which led basically to increased maintenance and a lot of steam losses. So we solved this by using a very flexible graphite packing set in combination with live loading. And basically the result of this was that the valve is running leak-free, leading to savings in maintenance and a lot of savings in steam leakage. And basically with a 5-year sealing guarantee, this saves a lot of money. So I would like to give the controls now to Vitaly and Enrico, so we can talk about mechanical seals. Thank you very much.
Thank you, Hans, and thank you everybody for attending up to now and to see the last session of today's webinar. It's dedicated on how mechanical seals can help you in saving energy and water consumption in your plant. So next slide, please. Mechanical seal is that small element that we can find in many centrifugal equipment like a pump or like a mixer, and it can be considered as the heart of the reliability of the rotating equipment. Some mechanical seals, to work better, need some external pressurized clean water flush to work in order to dilute, for example, the solids in the seal chamber. And some other mechanical seals, due to high frictions in the seal faces, are consuming excessive energy, and that's what we will see in this session today. So, next slide, please. We will see how to reduce seal water consumption thanks to spiral track device, the same that we use for the packing, faces hard material, and faces design. These are the 3 ways we can help to reduce seal water consumption. The first one is the spiral track. The spiral track device is a static device that we put in the bottom of the seal chamber, and that makes the job of cleaning the seal chamber from the solid. That's the reason why you do not need any more the water for the flush, or you need 10% of what you are using before. Because a spiral track, Vitaly, can you please try clicking on the video play? The spiral track function is to remove the solids from the stuffing box. What we see here in the video is a plexiglass pump with solids, and that's the situation without the spiral track, a situation where the solids are harmful for the sealing system. Now, if we put a spiral track in the bottom of the stuffing box, you can see that black device. This internal spiral groove will suck the solids away from the sealing system. We already have now, after a few seconds, the clean seal chamber, even if the process is dirty. So that's why we don't need flush. That's why the spiral track makes the job and helps you to reduce the flush to make the seal work better. The second way to reduce the flush is to use hard phase. For example, our reaction bonded silicon carbide material has a hardness of 9.7 on the Mohs scale. What you will see here in the picture is, for example, the Chesterton 442 split mechanical seal with a hard phase combination that can work flushless. Thanks to that, except if you are pumping diamond powder that is harder than these phases. But otherwise, our phases material is so hard that a lot of organic solids will be crushed by the phases, and that's why we do not need to protect the phases with additional flush. So hot phase material help us to reduce or eliminate the flush water consumption of the mechanical seals. And then the third solution that we can offer is the phases shape, the phases geometry. So all mechanical seals have at least a couple of phases, a rotary phase and a stationary phase. And we in Chesterton, we like to build up the phases with the monolithic concept. So phases with a high torque construction to withstand the torque common to the slurry handling applications, and in the heavy duty seals like the one you see in the right hand corner, so the 1810, 2810 Chesterton new heavy duty mechanical seal, we also create a micro polished O-ring working area on the outside diameter of the seal face. That's what you see on the second picture. So that allows the O-ring to continuously work dynamically, even if we are pumping slurry, avoiding clogging. So that's why here again, we don't need to have a lot of flush, and we can also work flushless because we have these technical features around the phases shape to make them work without the need to dilute the process. And we have many experiences on that, of course. You can see an example here. I guess that my image has frozen. So you can see some examples here. That's an example from a coal-fired power plant where some slurry ducting pump has been upgraded to a Chesterton heavy-duty flushless mechanical seal. This solution, coupled with the advanced reinforced composite MX2, allows the pump to run much longer without the need to care about the flush. So what are the advantages of reducing the water consumption and, of the mechanical seals? First of all, the plant creates less wastewater, which in turn uses less energy and costs less money to the plants. In addition, the process is not diluted. That's especially true for the paper mills. If you are using too much flushed water, you are diluting the paper stock, and you need to spend additional money to heat that up and to evaporate this additional amount of water. So you have also clear savings in not diluting your process just to protect the mechanical seals. That's why it's useful to have flushless mechanical seal. Finally, you comply with the government legislation, and you can propose to your customers some environmental friendly goods. And that's exactly the same thing that we offer with the energy reduction with the mechanical seals. Our mechanical seals are balanced. This means that they will consume less energy because they have less friction. That's the case based on my personal experience on KSB liquid ring vacuum pumps, where the non-balanced original mechanical seal has been replaced by a balanced mechanical seal. And the customer itself noticed that the pump was absorbing 2 ampere-hour less than before with a amperometer. And these 2 ampere-hour less than before are worth around 80 euros per month, which after 9 months just paid back the investment of improving the seal from non-balanced to balanced. And after the 10 months, it's a net saving for the plant, just considering the energy, not considering also the advantages of the longer life. So as a conclusion, what is the topic behind the balanced design? A balanced mechanical seal reduces the interface friction, resulting not only in cooler running and longer life, but also in less energy absorption. Let's see in detail what is a non-balanced mechanical seal. A non-balanced mechanical seal, we see here an example of a mechanical seal in seal chamber. So you have the pumped water at, so to say, 10 bar. And these 10 bars are acting all the way behind the rotary phase in dark gray to compress it against the stationary phase in white. Will that seal work properly? Yes, even too much. It will seal too much. There is too much compression between the black phase and the white phase. So that excessive friction will generate excessive heat, excessive energy consumption. This seal will, by the way, wear out quicker. So what's the trick? We want to offer a balanced design. It means to design the seal in a more appropriate way that we will see in the next slide, in order to reduce the surface where the process pressure acts to compress the phases. That's what we see here. So you see that compared to before, we have additional O-rings that, by the way, protect the springs from being in the process fluid. But it means also that these 10 bar of water, for example, are acting only on that small red area that is defined by what we call the balance line. And that balance line shows that the compression between the black rotary phase and the white stationary phase is just 70%, so 30% less than what it would be with a non-balanced seal. So that's the reason why we have less compression, less friction, less energy absorbed. And as a final conclusion, we can even go further than that with a zero friction seal, the contactless 4400 gas lubricated seal, where there is no contact at all between the rotary and the stationary phase, because the phases are running on a cushion of gas. So that's a real seal with no energy consumption at all. So as a conclusion, the mechanical seals as well can help you to reduce your water consumption and your energy consumption. And using energy more efficiently is the fastest way, cost-effective way to save money, to increase the plant competitiveness, and to comply with the government policies and meeting the consumer expectation to sell environmental friendly goods. Thank you for attending. Vitaly, I'll let you the parole.
So thank you, Enrico. Thank you, everybody. Thank you, all the experts. Maybe you can go switch off your cams, switch on your cams to say hello and goodbye to every participant. I know we have a lot of questions, but anyway, we will share the presentation after this webinar, and we will answer your questions, and you can also ask our experts for their expertise. So thank you for this dynamic webinar, and I wish you you will join us to the next session in December, on the 16th of December, and have a nice day. Thank you. Goodbye.
Thank you all.
Bye-bye.
Thanks.
Bye-bye.